So this problem is, two kittens are on opposite sides of a field, 250 meters apart. Kitten A runs at a constant speed of 25 meters per second due east on a collision course with kitten B, which is traveling west at 12 meters per second. How much time elapses before the two kittens collide? So what I'm going to do is I'm going to try to draw a visual situation for myself. So right here, this is one side of the field, this is the other side of the field. The distance between the two sides of the field is 250 meters. So I can say that this is 0 meters, this is 250 meters. Kitten A. So this is A. It is traveling due east. So this direction. At a rate of 25 meters per second. It is on a collision course with kitten B. Kitten B is traveling west at a rate of 12 meters per second. We are trying to figure out at what point they end up colliding. No, Kitten A should probably have yours. Here we go. Because we have two separate objects, the way we're going to solve this problem is actually by identifying the variables for both of these separate objects. So I'm going to do it for Kitten A first, and then we'll do it for Kitten B. So Kitten A is going to start off at a position of 0 meters. We don't know its final position, but we're solving for time, not position. So I can just kind of eliminate that equation, maybe. My starting velocity is given. It's 25 meters per second due east. So this will be to the right, which is 25 meters per second. We're told it is a constant speed. That means the final velocity is the same, but really that also means that our acceleration is 0 meters per square second. We're trying to solve for time. Kitten B, it starts off 250 meters away. So I'm going to say that is its starting position. It's traveling in the opposite direction at 12 meters per second. It's safe to assume that it's traveling at constant speed as well, so that means it has the same acceleration, 0. And we're trying to figure out the same time. The way that we can end up solving this problem is by writing two separate kinematic equations that explains the motion of each cat. Because they're a constant velocity, the first equation up here, the v equals a times t plus v naught, is kind of pointless. It's not useful to allow us to figure out the times where these two collide. We need to focus on one that has time and position, which also eliminates that second equation. So really it's just going to be this last term. But because the acceleration is 0 for both these kittens, this last term goes away. So what we're really left with is position equals starting position plus velocity times time. So I'm going to write that down for Kitten A. Kitten A, we can quantify its position by taking its starting position, 0 meters, plus 25 meters per second. Its velocity times the time it is traveling for. We can do the same thing with Kitten B. Its starting position is 250 meters, minus, because it's traveling the opposite direction, its velocity of 12 meters per second, times time. Now, these two kittens interact and collide with each other when they are at the same position. So really, I can set XA equal to XB. So, to do that, I'm just going to take my 0 meters plus 25 meters per second times time equal to my 250 meters minus 12 meters per second times time. I'll try to isolate t by adding the 12 meters per second times time to both sides. So that's 37 meters per second times time is equal to my 250 meters. Then I will get my time by itself by taking that 250 meters and dividing it by 37 meters per second. So 250 divided by 37 is going to be 6.7, rounding up, it'll be 6.76 meters divided by meters would cancel out those meters. And then because it's 1 over seconds, that would bring the seconds up to the top, which would be the amount of time it takes for those two kittens to reach each other and collide.